All right, so there are a couple of periodic trends which we want to talk about when it comes to the table. So just patterns that we see when we look at the periodic table. The first has to do with atomic size. You'll notice that as you move down a group, the atoms tend to get a lot bigger. And this is because as you're moving down, so I'm going to put this going downward, we see that there is an increase pardon my writing, it's not that great. As you move down, you increase the size of the atom. That's because you're adding more protons, which means you're also adding more electrons. And so the more electrons you get, the more shells, electron shells you're going to have, and the more protons you get, the larger your nucleus is going to be. What is slightly unexpected, however, is that the size actually increases moving over to the left. Okay. We also see that on this right-hand side of the table, you're going to have smaller atoms than you do in the same period on the left-hand side. The reason for that is as you add more protons, there's more of that positive charge pulling the electrons closer and closer to the center. So it actually makes the atom shrink a little bit. So those are our first trends. We have the increasing in atomic size as you move down and to the left. So that means that our largest atom that we have is going to be cesium right here, which is in the bottom left-hand corner. All right, next we have atomic number, which you've probably figured out that as you move down the period, that number in the left-hand corner starts to get bigger. So we see that atomic number increases as you move down, and it also increases as you move to the right, because as you're moving across the period, you're adding one proton every single time. So between the going down and to the right, again, right here you see we're going to have the largest atom is going to be, the largest atomic number is going to be down, and it's actually going to be over here. This is an older periodic table, but it would be atom 118, because the larger the atomic number, the further over to the right it is going to be. The next one we have is atomic mass, and again, I feel like this one makes sense. As you are increasing the number of protons and neutrons to your atom, you are also going to see an increase in that atomic number, and so the mass is also going to increase. So again, as you move to the right and move down, you're going to have the largest atomic mass. So right here, 118, that is our biggest number right there. So that's going to be the atom that has the largest mass. And finally, we have element reactivity. Now this one is a little bit more tricky. I've gone ahead and highlighted the metals in blue here, the non-metals in orange, and the reason for that is that metals and nonmetals react differently. So as you move to the left and as you move down, that's where you have your highest reactivity. So francium is the most reactive element that we have on the periodic table. Now if we remember from the groups, group 1, the alkali metals, they were highly reactive and they are the most reactive group of the metals. And remember when we got to the transitional metals here in the center, they said that the reactivity was not so great. And so that's how you can kind of remember, is that this middle part is not reactive. So as you move to the left, you're going to become more reactive, and then as you move down, you are also going to become more reactive. I blocked out the metalloids because since they have different properties depending upon the environment, we're not going to discuss their reactivity, but we are going to talk about the nonmetals. Now notice I put the arrow over the noble gases. The reason is, remember, noble gases are non-reactive at all. They don't react at all. So when we talk about non-metal reactivity, we're only talking about the nonmetals from group 14 to group 17. Now with nonmetals, they are the opposite of the metals. As you move to the right and as you move up, they become more reactive. So fluorine is actually the most reactive non-metal on the table. And again, we ignore the noble gases because they don't react.